Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Today we'll be solving some questions of term 2 from a mock test paper. So let's begin. Transition metal with lowest atomic number is the first element, scandium, with atomic number 21. Molecular formula of ethers is CnH2n plus 2O. It's isomeric with alcohols. Which of the following is not present in DNA? So uracil is present in RNA and not present in DNA. Dettol is used as antiseptic. Which is used as tranquilizer? It's equinol. Aluminium crystallizes. This is from term 1. Transition elements have high boiling points and melting points. Why? This is because of involvement of greater number of electrons from N-1d and Ns electrons, so that the interatomic metallic bonding is large, and so the boiling points are high. Compare the similar properties of lanthanides and actinides. So similar properties of lanthanoids and actinides both have +3 oxidation state. Predominantly, both series have f orbitals which are progressively filled, and both actinides and lanthanides have same number of unpaired electrons, have quite similar spectra, and like lanthanides contraction, there is actinide contraction. So these are the similar properties. What is Wood's reaction? In Wood's reaction, we react alkyl halides with sodium in presence of dry ether to form alkane with double the number of carbon atoms, and alkane with even number of carbon atoms is formed. What is dehydrohalogenation reaction? So in dehydrohalogenation reaction, a hydrogen from the carbon adjacent to the carbon carrying functional group and the halogen atom, they are removed when they reacted with alcoholic KOH. HBr is removed and a double bond is formed. This HBr combines with QH to form KBr and water. So alkene is formed. Write reactions of final alkylation product of aniline with excess of methyl iodide in the presence of sodium carbonate solution. So when aniline is reacted with methyl iodide, the H and I combine to form HI, which is removed, and this methyl group gets attached in place of H. So methyl, N-methyl aniline is formed. The reaction will continue further as there is still more hydrogens present here to form dimethyl, N-dimethyl aniline. And then another molecule of methyl iodide is added to form trimethyl anilinium iodide. This is the final product. Write chemical reaction of aniline with benzoyl chloride and write name of the product obtained. So aniline reacts with benzoyl chloride in the presence of aqueous NaOH to form N-phenyl benzamide, HCl. This H will combine with this HCl with this Cl to form HCl, and COC6H5 gets attached here. N-phenyl benzamide is formed. Write short note on denaturation of protein. So a process that changes the physical and biological properties of protein without affecting the chemical composition is called denaturation. Certain physical changes like change in temperature, or chemical changes like change in pH, presence of salts, or certain chemical agents causes denaturation, in which the globular protein gets uncoiled in presence of denaturing agent to form uncoiled denatured product. The helix gets uncoiled and protein is precipitated. Write IUPAC name of following coordination compounds. So to write down the IUPAC name, we first find out the oxidation number. So X plus minus 1 is equal to plus 2, because this is minus 2, this is plus 2. So X minus 1 is equal to plus 2, minus 1 goes to this side, X is equal to plus 3. So name will be pentaamine bromido cobalt sulfate, cobalt 3 sulfate. For this compound, the oxidation state comes out to be, because this is plus 3, this is minus 3. So X plus 6 into minus 1 is equal to minus 3, and X is equal to plus 3. So name will be potassium hexacyanido ferrate 3. Next is potassium trioxalato chromate 3. These are the IUPAC name. Next, why propanol has higher boiling point than that of hydrocarbons? Because in propanol molecules, there is strong hydrogen bonding. More energy is needed to break this bonding, so boiling point is higher. Whereas in hydrocarbons, there is only weak van der Waals force of attraction, so its boiling point is less. What are natural and synthetic polymers? The polymers which are present in nature, like starch, cellulose, rubber, protein, nucleic acids, etc., are called natural polymers, whereas the polymers synthesized in the laboratory, like nylon, PVC, terylene, etc., are called synthetic polymers. How can you differentiate between addition and condensation polymers? So, in addition polymers, different monomers add to each other to form polymers. In condensation polymers, monomers combine with loss of small molecules like water, ammonia, HCl to form polymers. Nothing is lost during the polymerization process. Small molecules like water, HCl, etc. are lost. Polymerization generally involves one monomer. It involves two monomers. Monomers are unsaturated compounds containing double bonds. Monomers contain two functional groups. Examples are polythene, polyvinyl chloride. Examples are nylon, terylene, bakelite, etc. Then next is what are Etard reaction and Gattermann-Koch reaction? So in Etard reaction, toluene is oxidized with chromyl chloride in presence of carbon tetrachloride to form this product, which finally releases benzaldehyde. Whereas in Gattermann-Koch reaction, benzene reacts with carbon monoxide and HCl in presence of anhydrous aluminum chloride and cuprous chloride. These combine to form formyl chloride, which reacts with benzene to form benzaldehyde and HCl. This is Gattermann-Koch reaction. Aldehydes are more reactive towards nucleophilic addition reactions than ketones. Justify. So, to understand, let's consider the action of a nucleophile on aldehyde. This bond being polar, oxygen being more electronegative, the electrons are attracted towards oxygen atom, resulting in a positive charge on the carbon atom. So the nucleophile gets attached to the positively charged carbon atom, and then later on a proton is taken by oxygen to form this addition product. Now, more the positive charge on carbon atom, greater is the reactivity. Aldehydes are more reactive than ketones due to two reasons: electronic effect and steric effect. So a greater positive charge means higher reactivity. Alkyls have one alkyl group, ketones have two alkyl groups. So alkyl groups are electron releasing in nature. They decrease the positive charge because two electron releasing group decrease the positive charge mode, so reactivity is less in ketones. Whereas in aldehyde there is only one alkyl group, so the charge is decreased to a lesser extent, and so reactivity is more. Secondly, steric effect also increases the reactivity of aldehydes. The size of alkyl group is more than that of hydrogen. In ketones, there are two alkyl groups, so more hindrance is caused to the attacking reagent, so the reactivity is less, whereas in aldehyde there is only one alkyl group. So that's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.